Okay, so I'm still doing medium problems for now until I get sick of them, because I couldn't solve a bunch of hard problems in past few days / weeks. So bulb switcher, there are n bulbs that are initially off. You first turn on all bulbs, then you turn off every second bulb, every third bulb. Okay, return the number of bulbs that are on after n rounds. Well, we could simulate, but that would be n times n half plus n third plus blah blah blah. So that's n squared. So instead, let's count how many times does a bulb have to be. So first we turn them off. So one is always turned on. If we have two of them, well, you turn off every third, and then you turn off then you flip every fourth. But fourth has a divisor of 2 and 4. Or should I say 1, 2, and 4. Therefore it's gonna get 3 times, so it's gonna be on, because you turn it off by 2 and turn it on by 4. Okay. Okay. Therefore, if we know the number of divisors of each number, we could solve this. But since n is 10 to 9, that's probably not a good approach. So this wants some math. Well, it depends how many divisors does a number have. So let's try that method. So I is if n return n int count is 1, no 0 for int I plus plus, int divisors for int d is 1, d times d I d plus plus, if I percentage d equals 0, then we do cent plus plus, and then we do, oh, this is ans plus equals cent percentage 2 and return ans. That's tough. Why is that? Well, if I divided by d doesn't equal d, then like that. Okay, so I change the test cases. It's gonna be 2, 3, 4, 5, 6, 7, 8, 9. Okay, I can do more, so let's see what will be the answers. I got it wrong for 7. Why is that? Should be the number of the divisors. I don't even have a paper to write to anymore. So let's say for 7 we have, so first I turn all on, then I turn every second off, then I turn every third off, 3, 4, 5, 6, So I flip first all of these, then I flip these, then I flip 1 2 3 1 2 3, no, these, okay, then every fourth, so this, so 1 0 0 1 1 1 1, then every fifth and every sixth and every seventh, so that should be 2 and y is output 3. So 1 has 1 divisor, 2 has 2 divisors, 3 has 2, 4 has 1 2 4, 5 has 2, 6 has 4, and 7 has... How does 7 have 3 divisors, bro? What the shit? Should belong here, I think. Like that. Okay. So it's 2, 2, and then for 9 it's 3. So I have a theory. My theory is so these get turned off. So 1 2 3 4. Well, let's pretend we do n is I don't know, 33. Let's run it. What do you mean? What is not a test case? Okay, I don't care about the test cases, bruh. I need just one now. One, 4, 9, 16, 25. Okay, so we can clearly see a pattern where we are basically interested in elements with even number of divisors or odd number of divisors. And here it's 1 3 9. Oh, okay. So it's actually pretty easy. I understand it now. We are looking for positions which have odd number of divisors, but everything except one has even number of divisors only except when it's divisible by its square root. So only numbers that are powers or second powers of some numbers can be like 9, square root of 9 is 3. So the answer is very, 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 very simple. So I want to do int answer is this. Int m is 1 while m times m smaller than n. Then we want to increase ans and increase m, and we return ans. Boom. So the answer is just square root. So return square root of n, I think. Let's see if I can get this first right. 1 0 69. Okay. That is the stupidest problem I've ever seen in my life. Okay, well, at least I came up with it myself. Okay, funny math. Lamau, okay. intuition. Light bulb will stay on after switching if it has odd number of unique divisors. Which numbers have odd number of unique divisors? Each divisor d of number, if number has a divisor, if number n has a divisor d, then the number n divided by d is also a divisor of n. So do all numbers have only even number of divisors? Well, if d equals n divided by d, well, if d is n divided by d, then square root of n divides it, and it does not have a pair divisor. Therefore, only numbers that have a integer square root have odd number of divisors. There is squared n of them among the first among 0 to n. I'm not sure how fast you can actually, if we can calculate, but squared is not in O1, I think. Might be like log or something. All time to calculate this square. I mean, I guess it's squared n. If we just iterate until we find largest square number, or O of I'm not sure if it's O1. I lean towards no. O1 since we use only handful, since we or the library use only handful of extra variables. Okay, funny problem. This was great problem and only 15 minutes. So goodbye.